Okay, hi everybody. So today I'm going to go over Unit 5A before your test tomorrow. So Unit 5A is about exponential functions, right? Exponential functions. And we've been working on this unit for the past 2 weeks. It's a really short unit. That's why your test is coming up tomorrow. So if I were you, I would get a whiteboard or a piece of paper and something to write with so that you can follow along and practice. Of course, I gave you the other assignments to work along, but if you have chosen to watch this video, I think it's a good choice. So let's do this, okay? So I have chosen some problems from the Desmos and from other practice problems. So let's first do this one, okay? So the first one we're gonna do is we're gonna simplify exponents. So 5 squared times 5 to the 4th power times 7 to the 0th power. So here we're multiplying exponents. This is the power rule because we're only multiplying, okay? When we only multiply exponents with the same bases, of course, in this case, we can only multiply the 5s together because 5 has the same base. So if we multiply the exponents with, it's going to be, you're going to add the exponents, it's going to be 4 plus 2, which is 6. Because 7 to the 0 power is not of the same base of 5 with 5, we're just going to bring it down. But we know that anything to the 0 power is just 1. So it would be 5 to the 6th power times 1, but when you multiply 1 with anything, it just becomes 5 to, in this case, it's going to be 5 to the 6th power. So 7 to the 0 power didn't really matter in the first place, right? So your answer in this case would be 5 to the 6th power. I know I'm going a little fast, but of course, if I'm going a little bit fast or you think it's a bit too slow, you can adjust the YouTube speed however you would like. And you can pause the video and you can go back if you need help. All right, let's move on. Let's do a little more simplifying. Okay, this time we're going to use division, right? We're going to divide 4 to the 10th power, divide by 4 to the 3rd power. Hopefully this is familiar with you. You're familiar with it. Sorry. It's a little late while I'm recording this, so I'm a little tired, but let's do this. So when we're dividing, same bases, they have exponents, 4 is the same base, we just subtract the exponent. So it becomes 10 minus 3, which is 7, 4 to the 7th power. That's it. Okay, let's see, it's going to be a little more tricky now, okay? So, 3 to the 5th power, 3 to the 10th power. If it's square, like it's power of a power rule, the 2 is outside the parentheses. So we want to get rid of the parentheses. We're going to distribute into this parentheses. It's going to be 3 to the 10th power because 5 times 2 is 10, and then 10 times 2 is 20. But we are not yet done. 10 and 20, we can divide, right? We can divide this number, has the same base. 3 is going to be the base, but 10 minus 20, be careful, 10 is smaller than 20, so it's going to be 10 minus 20, which is negative 10. But as in class, we do not like negatives. So instead of writing 3 over negative 10, we're going to flip it over. It's going to be 1 divided by 3 to the 10th power. Okay, nice. Okay, so let's continue. Let's move on. Hopefully get some harder problems. All right, we have a more difficult problem right here. So it's going to be 5 to the 3rd power times 5 to the 7th power squared all over 5 to the 20th. In this case, we're going to distribute. So when we have fractions, you see the fraction, we're going to focus on the top part first. See, I'm going to put this ruler to block out the bottom part. We're only going to focus on the top part first. So let's distribute the 2 with the power of a power rule on top. Okay, so if we distribute it, it's going to become, let me erase that, 5 to the 6th power times 5 to the 14th. We're just multiplying those two numbers by 2. Okay, let's bring down the fraction bar. 5 to the 20 just stays. Okay, so what can we do here? I'm going to move my numbers over to give us more space. Oh no, my number. Oh no. Let me try that again. Sorry. There you go. Okay. So on the top, if we just focus on the top, we see power roll. Right. Oh, I've been saying the wrong thing. It's product roll. Guys, I am tired. I'm sorry. It's product roll. Okay. So we're going to add the exponents. So 6 plus 14 is 20, right? We add the exponents on the top. And then on the bottom, 5 to the 20 stays as well. If we know, when we divide anything by itself, right? If you divide the same thing, like the top is the same, divided by the bottom is the same, 5 divided by 5 is 1. So in this case, 5 to the 20th power divided by 5 to the 20th power is equal to 1. We could also look at it this way. 5 to the 20 divided by 5 to the 20. We subtract the exponent, so it becomes 20 minus 20, which becomes 0. Anything to the 0 power is 1. Uno. Okay? We move on. Again, if you need, I'll give you time to pause if you need to. Okay, so let's do a few more heavy exponents. All right. So I'm going to do this one. I'm going to change up the numbers from this example. It's going to be negative 3 times 2 to the 4th power times 7 to the 0th power. You might see this, okay? So, and I'm also going to add one more thing, times 5 to the negative 1. Let me write it in blue. Times 5 to the negative 1. We know that we don't like negative exponents, right? This is not a negative exponent. It's just a negative 3. So the only thing, there's two things that we need to change, right? We don't like this negative exponent, and this 0, right? Anything to the 0 power becomes 1. So if you see anything to the 0 power, just cross it out, okay? That equals 1. It doesn't really matter in this scenario. Okay, the only thing we care about is this negative 1. Remember, every whole number is being divided by 1 at all times. It's just this division sign and the 1 is always invisible. But we know we don't like the negative 1. So what we're going to do is we're going to take the negative 1 and move it to the bottom of our fraction. So on the top of our fraction, negative 3 is going to remain. 2 to the 4th power remains, but on the bottom it's going to be 5 to the 1st power. We have moved it to the bottom. The magic line in the middle has turned our 5 to the negative 1st power into 5 to the 1st power positive. Okay, so we are done because all of these have different bases as well. Okay, so let us continue on. Okay, let's try to find more difficult problems. This is the last one. Okay, last one, and then we'll move to scientific notation. If you think you're good with this, you can skip, but if you need help, yeah, it's great to listen along and follow along. If you're not writing along with me or trying it, there's no point in watching this, okay? You need to do the math. You got to do the work. If you just watch and say, oh, I'm watching, I'm learning, yeah, it's not going to happen. Learning comes from you doing it, not just from you looking at somebody who's done this thousands of times. Do it over and over again. So please, if you can, write this down. Write it down, try it, pause the video, whatever you need to do to learn. Okay, so let's get started. Okay, if you need to pause, but I'm going to get started now. So first of all, I'm going to focus on this the top of the fraction, the numerator, right? I want to get rid of the parentheses, so I'm going to distribute into the parentheses. So I'm going to multiply the 3, so it's going to be 4 to the 6th power. I'm going to multiply the 6, 4 to the 12th power, and then I'm going to leave the 4 to the negative 3 power on top still. I want to do things one at a time. But on the bottom, I see product roll, right? I can see the 5 and the 2. I can combine it, right? 7's going to be still on the bottom, And then, but I'm going to add 5 and 2, 5, 6, 7. Okay, let's continue. I see here that I can combine these three 4s, right? Product rule again. If I add the 6 with the 12, that's 18. And 18 minus 3 is 15. So it's going to be 4 to the 15th power divided by 7 to the 7th power. Okay? Let me make this look nice, a little bit nicer. Okay, that's it. Because 4 and 7 are different bases, so we are done in this case. Okay, let's do 4 more problems, and we're going to do scientific notation now. Scientific notation. And we're going to do adding, subtracting, multiplying, and dividing. So let's get started with, let's do a subtraction one first, okay? So we're going to take 6.78 times 10 to the 4th subtracted by 4.13 times 10 to the 2nd. We are subtracting in this scenario, okay? And as we remember, when we add and subtract scientific notation, the exponents need to be the same. The exponents here are 4 and 2. Yeah, so I really like to make the exponents the same by making the smaller number into the bigger number, right? 2 is the smaller exponent. So in order to make it a 4, I'm going to add 2 to our exponent. And if we remember, when we add 2 to our scientific notation, we move to the left. So I'm going to move my decimal 1 place to the left, 2 places to the left. So if I rewrite everything, 6.78 times 10 to the 4th stays right there. It's going to subtract 4.13 times 10 to the 4th, but I need to move my decimal 2 places over. So it's going to be, let me erase this, 0.04. So 0.0413 times 10 to the 4th. I moved my decimal place 2 places to the right, right? 1, 2, 2 places to the right, so that it could become a 4. So let's do the math now. If I did 6.78 minus 0.0413, it would equal, okay, oh, yes, I do have a calculator. It would be, I'll put a decimal. It would be 6.739 times 10 to the 4th. See my tool? It's pretty cool, right? So guys, you would take the front number, right, 6.78, subtract it by 0.0413, and you would get, yeah, the number in the front, 6.739, and then you keep the exponent, okay, times 10 to the 4th. Okay, that's my example for subtracting. Okay, I'm going to erase. Okay, let's now add. Let's find an add. That's adding scientific notation problem. So we're going to take, let's do this one, 6.7 times 10 to the 7th plus 2.6 times 10 to the 5th power. So we see how 5 is smaller, right? And we need to add 2 to make it into a 7, just like this 7. So let's move my decimal 2 places to the left. So if I were to fix it up, I'll put a 0 there, and I'll put my decimal point right there. Let me rewrite everything so it's neat. So it's going to be 6.7 times 10 to the 7th plus 0.026 times 10 to the 7th. Can you see what I did there? If you can't, pause, think about it, take your time, okay? So, so if I were to do that, okay, yeah, my calculator definitely helps me a lot in that case, but I'm going to do I'm going to first subtract the first numbers, right? The 6.7 and the 0.026. Let's see what it equals to. Nice, okay. So it's going to equal 6.674, And then remember, we keep the times 10 to the 7th. It stays the same. If we're adding and subtracting, exponent needs to be the same. Okay. So there we go. Now we're going to divide. Okay. So let's actually divide or multiply. Let me see. Let me choose. Okay. Let us choose. Let me go to the next page. Let us divide. Okay. So we are going to divide now. Let me circle that in purple. And okay, we're going to take 1.2 times 10 to the 5th and divide it by 6 times 10 to the negative 2nd. All right, so in this case, let's start. This, I really like multiplying, dividing. It's much more simple. Just take it one, like, it's really simple. You don't need to make the exponents the same. First things first, we're going to take 1.2 and 6 and divide it first. That's the first thing that we do. Let's take 1.2 divided by 6 equals, let's see what it says. Okay, this is my calculator. You can use your calculator to help. Okay, please work. Okay, 1.2 divided by 6. Let me just use my phone calculator. Calculator. 1.2 divided by 6 equals 0.2. Okay, so first number is 0.2. And then we know when we divide exponents, we subtract the exponents. So it's going to be 0.2 times 10. 5 minus negative 2. What is that, guys? It's basically 5 plus 2, which is 7 to the 7th power. But again, we need to check if our number is in scientific notation. Right now, that is not in scientific notation. 0.2 times 10 to the 7th isn't in scientific notation because our decimal point needs to be behind the number 2. Okay, so if we move our decimal place 1 point to the right, remember, when we move to the right, we have to subtract our exponent by 1. So it's going to be 2.0 times 10 to the 6th power, and this is our answer. Okay, I might do 2 more examples because, this is difficult, and it's always good to have examples. Again, if you get it, you can skip and do your work, or this is just for your benefit and for your help. So let's do multiplication. 3.2 times 10 to the negative 3 times 5 times 10 to the 7th. I'm going to use a dot so I don't confuse us, right? I think if we use a dot, it might look a little better. So I'm going to put parentheses around this as well so we know what we're doing. Okay, so in this case, we're going to do 3.2 times 5 first. If we do 3.2 times 5, I'm going to get 16. There we go. And then times 10 to the, hey, when we multiply exponents, we add them, right? Negative 3 plus 7 is, you go backwards, 7, 6, 5, 4. Okay, so it's 16 times 10 to the 4th power. But this is not in scientific notation. My decimal point is right there originally, right? 16, and then your decimal point. I'm going to move my decimal point 1 point to the left. And we move our decimal 1 point to the left, we add 1 to our exponent. So it's going to be 1.6 times 10 to the 5th power. Nice. So always check whether or not your decimal point is in the right place. Okay? All right. We're just going to do one more problem. I think division can be tricky, but I think you guys can really do it. So let's do it. So let's do this one, okay? 2.97 times 10 to the 8th power, right? Divided by 2.2 times 10 to the 1st power. Okay, first things first, we're going to take 2.97 and 2.2 in our calculators and divide it up. So 2.97 divided by 2.2. Let's see what that equals. And my calculator right here doesn't work. I'm going to use my handheld calculator. Okay, it didn't work, so nope, did not work. So I'm going to do this in the calculator. It becomes 1.35. So 1.35 is the number in the front, right? And then it's going to be times 10 to the, we take 8 minus 1. 8 subtracted by 1 is 7. Okay. Ask yourself, is my decimal point in the right place? And the answer is yes, you are. Okay, really quick, converting from scientific notation to standard form, and standard to scientific notation really quick. So 0.000067, right, is this is not in scientific notation. It's not times 10 to the 7th power, whatever. It's not, right? So we need to make it. We want to make it into scientific notation. So if your quiz question, test question tells you to make it scientific notation, I'm pretty sure you can do it, okay? You guys were very good at this. I hope you continue practicing until you fully understand scientific notation. But let's do it. So I'm going to move my decimal to the right because my decimal point needs to be over here behind the 6. Okay, so let's move 1, 2, 3, 4, 5. If we move 5 to the right, we are subtracting. Remember, when we move to the right, we are subtracting. So my number will become 6.7 times 10 to the negative 5th power. Okay, and then let's go from scientific notation. If you need that, sorry, pause the video if you need it. Okay, if you want to go from scientific notation to standard form, this is how I would do it. Okay, so in order to get rid of the negative 3, we need to add 3, right? And if we add 3, we need to move our decimal point 3 places to the right. So if I rewrite 5.7 and move it 3 places to the right, 1, 2, 3, and then my decimal point will be right there. So I'm going to add a 0 and a 0 in those spaces, okay? And then now, if I want to rewrite it one more time to make it more clear, it's going to be 5. I made a mistake, y'all. I have made a mistake. I'm so sorry for recording it so late, but remember, when we add 3, we move to the left. So we're going to move to the left, 1 space, 2 space, 3 space. Okay, so I'm going to put a 0 right there and there, and my decimal point goes to the end. So if we rewrite this, it's going to be 0.0057. And as we remember, this number that we had right now earlier, the exponent is negative 3. If the exponents are negative, that means my number is going to be less than 1. If our exponent, let's say 6.2 times 10 to the 5th power, because the exponent is a 5, our number is going to be bigger than 1. 1, 2, 3, 4, 5. Okay, so this would be the number. Okay, if you have any questions, ask your neighbor, okay? Or ask me when I get back. Test tomorrow. Good luck. Bye.